So my goal for today's lesson is that I'll keep the motivation and enthusiasm intact throughout the session. I'll try to be highlighting more on the participatory activities, which was kind of, yesterday was very learning type, right, on lecturing kind of things. And then also work on making the topic connected to your heart or connected to real world scenarios. All right, so are we good to go? Okay, so good afternoon, everyone. As you all know, my name is Abhishek Soni, and I would be basically continuing from yesterday's session, which is water to fuel. I got a bunch of exciting questions from all of you, and I hope to answer them in today's session. All right. So before that, there's a kind of information that today's lecture will be more of participatory kind of on that side, and I will ask some of you to raise your hands. If I will not see anybody raising hand, I'll just pick random. So yes, we'll be ready for that. Okay, so just a quick recap from yesterday's session that what we have learned yesterday. So yesterday's lesson we understood and learned about structure of water molecule, potential of water to generate fuel such as hydrogen. So here is a whiteboard, and I want one of you to take the lead and come on the whiteboard, please, and draw me a structure of water molecule. Who wants to go?
Water molecule?
Yes.
Sure. Your hand up. Verification.
Okay.
Was it H? It's H2O, right?
Okay. Yes.
Losing my marbles. There we go.
Great. And what's your background?
My background? Science.
Nice. That's a perfect answer. So that really aligns. Okay, great. So yeah, you can please take your seat. So that's the water molecule. So we had learned about this yesterday, and then we also learned about potential of water to generate fuel. So I will call another one from the group, except you, to please come here and how you think of from yesterday's lesson to generate hydrogen as a fuel. Anybody? Just recap from, please.
That's such a good structure.
Murder.
Okay, so what's that?
This is breaking the bonds.
Breaking the bonds, and how you will go doing that?
Whatever the process was.
Electrolysis, right? So breaking the bond can come from any source, right? You can put pressure. I don't know how much the bond will break. You can put electricity as a source of energy, so, right? Let's say electricity, right? And since we are breaking the bond, we are doing lysis of the bond, and this is called as electrolysis of water. Okay, so we have this now. Can anyone else come here and start teaching me how to draw the electrolysis process? And I'll guide you. Just if you remember.
Want to recreate the experiment, you mean?
Yes, I mean just what you will start with. Like you have a jug of water.
Yeah. You want
Yes.
me to talk and you draw, or you want?
Just start drawing. I'll help you.
Okay. So I think you'd have a vessel of water, right?
Great. If you can a little bit move so that others can see. Thank you.
Okay, so the vessel has water in it,
Yes.
and then you effectively have like two, diodes.
This is water. Yes.
So you have this something conductive. So I think you're using graphite. That means
Graphite
pencils.
pencil.
Yeah.
Yes.
And then so you will take these two wires to a battery that
Again, conductive connection,
had a,
so that the current flow is maintained, right? Because if you break, then you already notice that your bulb will start, falling off. You will not be able to produce electricity. So this is conductive, these ports are conductive, and then at the end, what you will see when you apply the current?
And that's why we add salt or something for the water, so the water is
Exactly.
conductive as well. So it
Exactly.
wouldn't work otherwise.
Because salt has ions, NaCl, right? Potassium and chlorine ions. So you have to make everything conductive. Great. And then what you notice once you apply the electricity, do you remember?
So then you get the separation causes like it's a bubble.
Yes. So bubble, that's another observation. And what those bubbles are?
I'm guessing hydrogen and oxygen, but that was my question, I guess, from yesterday, is it says it both, like the bubbles are indiscriminately either in gas,
Yes.
either element in gas form?
Yes, so they are generated in the gas form, but you also have to take care about the solubility of these bubbles in the solution in water, right? So that's certainly another area of topic which we can definitely discuss. But the main takeaway is that you generate hydrogen and oxygen, right? And then they start evolving over, and then you have some other container to collect them separately. Okay? Great. So we have now water electrolysis in everyone's head. Now let's.
I have one question.
Yes, please.
So, all these bubbles are coming from same vessel. How do they separate? Like
That's a very
one
good
vessel,
question.
Hydrogen, one vessel, oxygen. How they separate?
It's a very good question. So what people do, they put a separating membrane here as an advanced technology, act as a separator, which only takes hydrogen here and not allow the passing of those two. Okay. Yes, but that's definitely, people are working on that to making it more to an advanced technology and scalable technology, which could be another session definitely. But my question to you is, now can someone of you fill this blank? So we demonstrated the electrolysis of water, and then we break the maybe wind. Why don't you tell? So what bond we break of water to create what and what?
We create hydrogen and oxygen gas. I don't know what type of bond it is.
So could you please focus here?
Yeah.
What bond we are trying to break? So this is what? Oxygen.
Yeah,
This is hydrogen,
yeah.
and we are trying to break the OH bond.
Okay, so it's
Is that
all
clear?
OH, okay.
Great, absolutely, that's fantastic. So, I am going to now give you some worksheet because I left our lesson, sure, in yesterday's lesson to basically think about this question of drawing the graph, how much oxygen and hydrogen will be produced from 10 liters of water. Just think about this, right? Just this picture. And if you have a 10 liters of water, how much hydrogen and oxygen will be produced? So think and work in pairs. So you can I will give you 1 minute of time. If you can just draw a graph on this.
Yeah.
30 seconds left.
Yeah.
Do you want to try?
Sorry, Rob.
I want to have half of it.
But now that he's saying
one
time
time.
is important.
Maybe get half.
Just draw anything. Like
This is the oxygen lot.
Yeah, this is the oxygen
Now
plot.
he's introducing
So you're given
the times
oxygen
of
production
access,
over
and
time,
it's unlikely that it's
and
linear
I would like you to
time.
draw the hydrogen production over time on the same graph.
I feel like this is my intuition.
But this is linear, so this would
not
happen.
correct.
Convenient.
But I like to think.
Unless
Okay.
it's- unless
Yes,
it's-
I will take that and will explain
It's
since
like
we
what
don't
if-
have much
If
time.
you're only getting like the first one.
Okay, can I take that please?
Yeah, yeah.
Thank you. Thank you. Okay, so I would like to quickly discuss this. So most of you have drawn something like this, which is double the slope, right? And this is also correct, double the slope. We'll get to it, which is correct and not. But one person has drawn inside, right? So I'd like to know your thinking. Why did you draw here?
I don't think the hydrogen would be half of the oxygen.
But you
No,
have
no,
two
it's
hydrogen as compared to one
No.
oxygen, right?
Maybe it could be.
theoretically, so what is the equation? So you have water, right? You go to, what is the formula of hydrogen gas? Anybody? Just hydrogen gas.
Also
H2.
in a straight line.
Right? H2 plus, what is the formula of oxygen gas? Great. But you have two hydrogen here, you have two, that's balanced, you have two hydrogen but one. So you need to make two here so that two is balanced, but 2 to just 4. Okay? Then you will produce double the amount of hydrogen as compared to oxygen, right? From 10 liter of water, you'll produce 20 liter of hydrogen and 10 liter of oxygen. Is that making sense? All right, so this is, I couldn't get to the practical scenario, but I really want this session to get into your lab. So the next step is